أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. My name is Engineer Muhammad Idris. I will be presenting my research work on the effect of raft contact pressure on the axial capacity of a pile in a piled raft system in the proceeding of the first International Conference on Recent Advances in Civil and Earthquake Engineering, organized by the Department of Civil Engineering, University of Engineering and Technology, Peshawar, on 8 October 2021. Introduction to Piled Raft Foundation. The Piled Raft Foundation is a composite construction of three bearing elements, pile, raft, and the subsoil. These bearing elements act as a unit to resist the structural loads. The effect of these elements can be combined by taking into account the interaction factors. Introduction to pile capacities. The ultimate pile capacity of a pile is provided by the trip resistance and the skin resistance. The equation number 2 is provided here, which gives us the trip resistance of a pile, and equation 3 is for the skin resistance. However, this skin resistance further depends on the friction resistance, which is given in equation 4. However, in these equations, as you can see that the pile capacity is dependent on the normal effective stress which acts along the pile. Methodology of the research work. Methodology of research work includes boundaries for numerical models, material properties, types of case studies, and numerical modeling in PLAXIS 3D, and pile load displacement curves, and then conclusion. Boundaries for numerical models. Boundary for numerical model was selected as 1.2 meter cross 1.2 meter cross 1.5 meter box, as you can see in the plane view and elevation. Materials properties. The materials selected for numerical modeling are shown here. Sandy soil was selected, having a soil model of Mohr column of unit weight of 16 kN per meter cube, having a Young's modulus of 50 megapascal, and Poisson ratio of 0.34, having a friction angle of 33 degrees, and dial tensy angle of 3 degrees, and having interface strength reduction factor of 1. And the raft material was aluminium pallet, having a linear elastic model of unit weight of 26.5 kN per meter cube, having a Young's modulus of 68.5 megapascal, and Poisson ratio of 0.33, and thickness of the pallet was 30 mm. While the pile material was stainless steel pipe, having a linear elastic model of unit weight of 78.5 kN per meter cube, and Young's modulus of 198 megapascal, having a Poisson ratio of 0.2, and external dia of 25 mm and internal dia of 19 mm. Case studies. Two case studies were selected as for the research work. In the first case study, the pile was in contact with the pallet. However, in the second case study, the pile was not in contact with the pallet. In the first case study, surface pressure was applied on the pallet, and the change in the pile capacity was investigated. However, in the second case studies, under different surface pressure, the pile capacities, the load displacement curve for the pile was recorded. Numerical modeling in PLAXIS 3D. The raft was modeled as a pallet, as shown in the figure. The pile was modeled as volume pile, and to take into account the interface between the soil and pile, interface element was assigned to the pile at the side and the tip. Numerical model in PLAXIS 3D. This is the numerical model developed for the case study B in PLAXIS 3D. Deformed soil body is shown here as a point load is applied on the volume pile. The volume pile is clearly visible in the extruded view here. As you can see, volume pile, a point load is applied on the volume pile. The volume pile load displacement curves were recorded under different surface pressures applied on the pallet. Load displacement curve for the case study A. Two load displacement curves are shown here. This curve is for the single pile and this curve is for the pile in a Piled Raft system. This is a simple curve in which a load was applied on the pile and the load displacement curve was recorded in PLAXIS 3D. However, in this curve, under different surface pressure applied on the pallet, the load displacement values were recorded for the pile in a Piled Raft system, and under increasing pressure, the load displacement curves are plotted here. As you can see here that the load capacity of pile increases as the surface pressure increases. As you can see, for the single pile, at this displacement, about 400 Newton load is taken by the single pile. However, under the surface pressure of 58 kPa, it is having the same settlement. So the settlement, under the same settlement, the pile capacity is greatly increased when a surface pressure is applied on the raft. Pile load displacement curves for the case study B. As in case study B, the pile load displacement curve was recorded under different surface pressure applied on the pallet. As you can see, when the pressure is increased, the displacement of pile reduces. However, the pile have taken the same load. As for this curve, the surface pressure was 0 kPa, and for this curve, the surface pressure was 10 kPa. As the pressure increases, so the displacement of pile reduces. However, the load taken by pile is the same. So, with the increase in the contact pressure, the pile displacement reduces and the capacity is increased. Conclusions. In Piled Raft foundation, the pile and raft share the structure load. When the raft resists the structure load, it causes to increase the vertical effective stress in the soil, which can increase the pile capacity. The pile settlement reduces greatly with the increase in the contact pressure of the raft on the side. The pile settlement can be reduced up to 30% by increasing the contact pressure of the raft on the side.